Hello, this is Mrs. Heinebach, and in this presentation, I'm going to tell you about separation or purification techniques. Purification techniques, in Dutch we call them scheidingstechnieken, are a number of techniques used to separate mixtures. And you probably think, oh, this sounds really boring. Yeah, the listing is maybe a bit boring. But what is the need to know about these? Now, in a number of manufacturing techniques, these are used to make things. Yeah, I've already mentioned this example of making sugar. We're going to see at the end of this presentation, or actually after this presentation, we're going to do an activity where we'll see that in the production of sugar, many of these techniques are used, and in your daily life you also will find some, and throughout the presentation I will mention them. And this brings me also to the reason to tell you why the second reason why I chose to study chemistry. I already told you about the fact that I love food and cooking and baking, and I wanted to know what happens actually while you do these activities. But the other reason I'm very happy I decided to study chemistry, or actually industrial engineering, and later I specialized in chemical engineering, is that I love to know how things work, how the world works, and how things are made. And maybe you've watched on Discovery Channel these programs, how things are made. So you have mechanical ways of making things, building stuff like furniture or things you use, or aeroplanes. But obviously also chemical things are made. And when we think of chemicals, we think, yucky, that's something that smells. But actually, if you don't want to use sugar, but you want to use sweeteners, like these little pills that are very, very sweet, though they are very, very small, now those sweeteners are, for instance, made chemically, but also all kinds of vitamins or additives added to paint or to lubricants. Say you want your bicycle doesn't cycle very well anymore. They say, oh, put some oil on the chain. But in that oil, that's not just pure oil. There are additives in there that help the lubrication of your chain. So these are all products made chemically, and now we'll take a look at the different separation techniques. There are about 10, and because that's quite a lot, and I'll be giving a lot of information, and personally I always find it very boring to just listen to a presentation like this one, especially if there's very little moving animation on the screen. I recommend the following study help. In its learning, you'll find a document which looks like this. Which looks like this. It's a big sheet, and here there are all the separation techniques. You see it is filtration, sieving, sedimentation, and decanting, which belong together, centrifugation, crystallization, solvent extraction, adsorption, evaporation, distillation, and paper chromatography. These are not all in the order I'll be talking to you about. You can print this paper, or just take a large piece of paper or several papers and make a table, or make just a summary. The items coming about are description. Each separation technique separates based on one or more different properties. So which property is that? That shows you really that you understand. If you know that and understand that, that shows that you really understand the technique. You can only separate mixtures. A pure substance you cannot separate, because you just have got to do with one kind of molecule. So it's always a kind of mixture. So which kind of mixture? I'll be talking about some examples, and then for each separation technique there will be a number of keywords important. So list these, and then you can make a drawing or a visual representation of this separation technique. And you can also write down the Dutch name. as this will come back in the upper grade, but very, very brief. And so that's why it's important we do it now. So back to my presentation. We're going to start. So this is a starter. So what is a mixture? And I've got a question for you. If we were in class now, I would stop the presentation and give you a chance to think for yourself. And you can set this video to pause and think for yourself. Does the model below represent a mixture or a pure substance? Explain your answer using the words molecules and atoms. Now pause the video, think about this. And if you've just restarted the video, the answer is as follows. What you see in this picture here are molecules. Here you have molecules with two different atoms, a black ball and a white little ball. This could be water, for instance, also seeing the angle. And here we've got an element, but made up of two atoms. So it's a molecule of one single type, so we call that an element. And so we have got two different molecules, so this will be a mixture. And if we want to separate this, we can use different separation methods. Here's the definition of a mixture. Mixture contains multiple molecules. Each molecule can contain one or more types of atoms, also pure substance. The objective of separation is to separate substances. Mixtures are purified. And why would you want to purify a mixture? Now think of the production of medicines. If you are producing a drug, you don't want to have any impurities in there. Something that's used as food or as medicine needs to be pure for 99.9%. And anytime you make something, when you produce something synthetically, the reaction, we say a reaction takes place is this reaction that is produced. Now, what is produced can already be a mixture of two molecules, but it can be a mixture of even more molecules, because not always the molecule is produced that you want. So then after a production process, a synthetic process, synthesization we say, you need to purify. Okay, the first separation technique is actually one that you used when you were just a toddler playing in the sand pit, and you would take the sand and a sieve and separate the sand and the little stones, the gravel. And that happened based on particle size. So the bigger particles would remain in the sieve and the smaller particle size remain in the sand. And we do that also when we bake, when we sieve flour. That's also to add air, but we do that also to just make sure that all the flour is loose and there are no chunks in it. The first real scientific separation technique is called filtration. And here we separate a liquid and a solid. And a liquid and a solid we call a suspension. And for instance, sand and water is a suspension, or chalk and water. But also, if we maybe during Easter you squeezed orange juice, but you don't like the bits in it, or the pips, that's for sure not, but the pulp. And then you can filter your mixture. And also that is based on the particle size. And as I said, there are a number of keywords. You'll use a funnel to do this with a filter paper. This is if you do this in the lab, of course. In a production environment, this will happen at a much larger scale, and they'll use sieves with a very small mesh size. So then the mixture, the solution, the suspension will pass through the filter. The solid will stay behind, and we call that the residue. Anything that stays behind is the residue. And what goes through the filter is the filtrate. And be careful here, it's written in Dutch. In your book, you'll find it how it's written in English. And this is also done on on industrial scale with membranes. And here on the next page, you see that. The membranes can be simple, like tubes, where a mixture is led through, and very, very small particles can be filtered out. And you see here overall all the possibilities. So it can be micro particle range, and then we are looking at 10 micrometers, for instance, and that's really very small, because think 1 millimeter is already 1,000 micrometers. So 10 micrometers can be filtering out suspended particles, as I said before, but very actual at the moment. Viruses, they are so small, hundreds of a micrometer, and then we're already using ultrafiltration. Ultrafiltration is also, for instance, used in the process of removing alcohol from beer. Yeah, to make it alcohol free. So filtration with membranes. The second and third separation techniques is sedimentation, which can be sped up by centrifugation, or if it goes slower, we let it to decant. And again, this is to separate a liquid and a solid. Think of, here you see an example with muddy water, and it's based on particle size, but also on density. If we let a suspension decant, not decant, a sediment, like we're doing here, the more dense particles, the mud will sink to the bottom, and that's what we call sediment, and the water will stay at the top. And you still see here that it's not clear, so you would have to filter afterwards. But the first part you can then decant, which basically means to pour off. You would pour off then the water, leaving the solid behind. And if you want then the solid, then we will use another technique, coming back to that later. And here on the right, you see a centrifugation machine, and that's often used in the lab. So if you have a solid particles, and you want to then keep those solid particles, for instance, but you want to remove the liquid, you can then centrifugate, and then with another solvent, you can remove the solid. By the way, here on the left, you see the unit number. The number in brackets is the addition. So this method is explained in unit 1.6 to 1 in addition 1 and 1.8 in addition 2. Then we have crystallization. So crystallization is, you see here, the diagram. We'll heat the mixture in a heat-resistant reservoir bowl. Here we heat it with the Bunsen burner that we would have done in the lab, in a practical. You could try this time, but be very, very careful. You could dissolve some salt in water and then heat this solution, heat this for instance, in a pan again, and then see what happens. Be careful, because it gets very hot and the salt can spit. But basically what you get here is that a dissolved substance in a solvent, we call this a solution, we heat that, and the solvent will boil, will evaporate at its boiling point, and based also on the solubility of the solute, the solute will remain. So for instance, an example of mixture of salt and water. The water vaporizes, the salt crystallizes, and your salt is the residue. Then we get the process of solvent extraction, and there, for instance, we can use this if we have two solids. and we want to separate them. One would be then, the example is sand and salt. Sand, as you all know, does not dissolve in water, while salt does. So you can add water to this mixture of solids. The salt will dissolve, then you can filter the sand and then evaporate the water again, and you will have the salt left over. The process of adding the water and extracting the salt by using a solvent, that we call solvent extraction. Solvent extraction is also used in a more complicated method. Sometimes you have solutes that dissolve better in one solvent than in the other. Then you can mix these two solvents and allowing the solute to dissolve in one liquid better than the other. I've looked for videos about this or good examples, very hard to find. So we'll have just to do it with the explanation from the book. There are a few more things to know about this method. And that is that oil and water, they don't mix. So we can use this property to separate things. So really, when you let oil and water stand, and you can try that with some oil from the kitchen, sunflower oil, for instance, and water, mix that and then let it stand, and you'll see two layers. And the lower layer is the one with the higher density. So the higher density will sink, that's then the water, and the oil will go to the top because that has a lower density. And oily substances besides oil itself are white spirit, so wasbenzine. Hexane is also often used to dissolve things, especially in the industry, and petrol. Watery substances, except for watery, are ethanol. That's basically alcohol that you can drink, never pure, of course. And in between you have acetone, which is used to remove nail polish, for instance. And remember that like dissolves like. So this means that oily mixtures will mix with oil, and watery mixtures will mix with water. Then we have adsorption, and adsorption basically means to stick to something. Ad means towards each other, and you can use this method to separate impurities and toxins from a solvent. This is used for people who go camping in the wild and need to find water, but they're not sure if the water is clean. They can use something called active carbon, in the commercially sold as NORAD. And this is a black powder which you can mix in with your water, which will it's like a sort of a little sponge, and then not a sponge that will absorb, sort of like paper that will slurp up the water, but the particles will go into the little holes and stick there too, because just like when you have a small particle size where you have a lot of surface, something with a lot of holes also has a lot of surface. So here you see an example, the impurities with in the water, then you add carbon, and the impurities will stick to the carbon, and then you need to filter, and you're left with pure water. I believe that this is a good point to have a break in this video, so I'll get back with part 2, where I'll explain chromatography and distillation.